right, everyone. I am here with Jacqueline Nolis. Jacqueline is head of data science at Saturn Cloud. Jacqueline, welcome to the TWiML AI podcast.
Thank you for having me.
Hey, I'm looking forward to our conversation. We're going to touch on careers in data science as well as Dask, which is a open source project that your company is working on. But before we dive in, I'd love to have you share a little bit about your background and how you came to work in data science.
Sure. I had the odd circumstance where I fell into data science, which is to say, I started years ago as an undergrad in mathematics, and then I got a master's in mathematics, thinking I wanted to be a math professor. Then I realized, no, I don't want to be a math professor. I want to use math to like help businesses and stuff. So I started a job, which now today would be called a data scientist, but back then it was business analytics, and I just kind of grew. Like I worked at an e-commerce company doing forecasting for them, and then I worked. Um, in aerospace for a bit. And then I'm like, I want to go get more technical skills. I'm going to go get a PhD. So I got a PhD in operations research. My research was in electric vehicle networks, like where does Tesla put their charging stations? And
Nice.
about this time, the field was starting to get called data science. And while I was in my PhD program, a company, like a boutique consulting firm, was looking for data science consultants. And I'm like, yeah, I'll make some side cash as a PhD student. You kidding me? Um, and then I finished my PhD, and then I did consulting for full time for many years, to the point where I was a director and like started my own data science team at a consulting firm. And then I quit and started my own like freelance consulting business, and I did that for a few years. And then I said, I being a freelancer and working on your own is a lot of work, and that's very stressful. Like I would like to go back into industry, and so then I ended up. Now I'm here at Saturn Cloud having a lot of fun. So
Awesome. Awesome. Yeah, I
yeah,
think you were doing the freelance consulting thing, or maybe just at the point of
yeah.
transition when we first met. And the circumstance around our connection was for those who may remember your name or the panel that we did a panel discussion on advancing your data science career during the pandemic just about a year ago. Um, and that was your kind of wrapping up the independent consulting at the
That's
time?
right. And so it was like I was part of that panel. I'm like, I also am advancing my career by by trying to get a job again after working independently for several years. So
And if I remember correctly, you spent some time talking about your career search and kind of how that evolved for you and how the pandemic made it interesting.
yeah, because I did start looking for a job right at the beginning of the pandemic when there were like 3 data science jobs in the country available. Which I think now there are a lot more. I think we've kind of gotten back to normal from what I've seen. But
Uh-huh.
yeah, it was pretty touch and go in like what June, May of 2020, April of 2020. It was
Yeah,
a rough time.
yeah. So, I mentioned that will be talking about a couple of different things. One of them is you wrote a book on data science careers. You do a podcast on data science careers, and you're generally out talking about and helping folks kind of build their careers, get jobs in data science. How did that all come about?
Yeah, so that's interesting. I started like a couple years ago going to conferences and trying to give talks. And I'm like, the thing I really like talking about is like, how do you become a director? How do you get your first job? Like, I kind of always like thought that stuff was not, or like, how do you run a team effectively? And I
Mhm.
always thought that stuff could be talked about more like per hour than maybe some technical topics. And at one point, Manning, the publishing company, read some blog posts I had. And they're like, hey, do you want to write a book? And I'm like, do I want to write a book? I'm like, I never considered writing a book, but yeah, I do want to write a book. And so I reached out to Emily Robinson, and we actually had met several months ago because we were both giving talks at Day to Day Texas. And I said, Emily, do you want to come write a book with me? And she said, maybe give me a month. I'm switching jobs. And so then, then a month later, and I just switched jobs too. And then like a month later, we're like, yeah, let's do it. And so we spent like a year um, writing this book. And so like each chapter, like the first half of the book is like, hey, if you're not a data scientist yet and you want to get a job, how do you get the skills? How do you build a portfolio? How do you write your resume? And then the second half is, okay, cool, you're a data scientist. Now what? Like how do you think about
Mhm.
like making a good analysis? How do you know what do you do when a project is failing? Or how do you quit a job and get your next one? Um, And so it's really fun. And so Emily and I, we wrote this book. It, did pretty well. We're pretty happy with it. And we're like, we want to talk about this some more. And so then we made a podcast too, where now the podcast is each week we kind of talk about the themes of different chapters of the book. So yeah,
Nice.
so I guess the result is I kind of fell into it. But also it was a really nice venue because, I had been a data scientist for a bunch of years now. And I have all these thoughts. And I'm like, I would just like to get them out of my head and on paper. And I could just hand the paper to other people rather than keeping it in here.
So when you think about the first part of the book, targeting folks that want to get a career in data science, what are the kind of top insights that you've actually, in the book or, since writing the book for, how you go about that nowadays, beyond the usual, which I imagine is, have some portfolio projects,
Yeah.
build, get on LinkedIn and network, get on Twitter and network. Like what do you find are the non-traditional or the non-obvious, things that folks should be thinking about?
Well, I would say maybe I'm going to say the obvious stuff, but I'm going to think about it. Think about it this way, this different way, which is
Mm-hmm.
the data science field at the entry level, I think is starting to get pretty saturated, which is to say, maybe like when I was looking for jobs, it was, like 10 years ago, it was, oh, hey, you got a math degree? Cool. Come on, come in.
Mm-hmm.
And now, like, it's so many people want to be data scientists that it's getting trickier, which is not to say you can't get a job, but it's just going to take more thought and, maybe work to do that. And when people give the advice of make a portfolio, make a GitHub page, all that, what they're implicitly saying is, hey, people who don't have data science experience, like pure like data science job experience yet, companies don't know, hey, can I trust you to be a data scientist? Would you get here and know what you are doing and how to handle it? And so something like a portfolio or a GitHub page, things like that, they are letting the employer know, hey, look, no, you can tell I'm a data scientist because look at this cool side project I did or whatever. But that's not the only way you can do it. You could do something like, hey, if you're a software engineering job, you can try and start doing data science things within that job, before you look for your next full data science job. Or you can start by getting a data analyst job. And in that role, which is similar to data science, work there for a few years, then transition to data science. So it's not like the pattern is first you make a GitHub portfolio, then they hire you. It's like, yeah, it's like, think about what are the things that you can do, and your circumstances best. What are the things that you can do that will help employers understand you are a good fit for this position? And that may not be something you can do over a weekend. It may take years to really set that foundation to help you out.
Mm-hmm. Given the saturation at the early stages of data science careers now, are employers looking for different things? Are there different ways that folks can and should be signaling that they have the required background?
I think that the classic, like, build a portfolio, that's good.
Hmm.
Get something in your job, that's good. Things like boot camps can also be good, but also you need to do the work of like, hey, I've been to the boot camp. I'm going to take this job and make it like so obvious how, this side project I did as part of the boot camp, make it so obvious that this is just like what you're hiring for. I can do it. But I think more broadly, what I would say is, well, that's kind of intimidating to know that the field's getting more tight at the entry level. I would say at the, hey, if you have 9 months experience in one data science role, I think it is very easy right now to get another job, which is to say the hurdle between 0 and 1 unit of like pure experience is massive. So it may feel really hard to get that first job, but know that once you get that first job and you stick in it for like just a tiny bit, it should be much easier going forward. So it really is gonna, like, you are at the hardest part right now, people who are just trying to get in, and it
Hmm.
should get easier, hopefully, as as the your career experience progresses.
Do you find that that kind of tenure or churn in data science jobs, these early data science jobs, is more or less than other areas at like software engineering?
I don't know if I would say data science is more churn than software engineering. I guess it wouldn't surprise me if it was, but I don't know. Um,
Do you
but
have a
what
sense for the typical tenure for a first data science gig?
I will say, I mean, it's probably like, I would guess it's like a year and a half.
Hmm.
2 years average, which I think is probably similar to software engineering.
Yeah.
And I think the reason why you leave data science jobs is not that different than the reason you leave software engineering jobs, right? Like you don't get along with your manager. You don't agree with the company's missions. The hours aren't good. Like it's kind of like a lot similar.
Hmm.
Um, but I do think that the people I know who have left after 9 months of their first job, it's not like they left and then they couldn't get another job because they only had 9 months experience. It's like, wow, people see 9 months like, cool, you've worked somewhere and done something. Come on in. Like we are not a lot of experienced data scientists out there, so we are hiring pretty quickly at that level.
Hmm.
Um, and like disclaimer, what Jacqueline says is not a career guarantee. This is just what I've seen from people. Yeah.
Yeah, it's a little bit of a contrast to some of the memes that you see, like for taking Dask for example, to start our transition over to that topic.
Sure.
Data scientists wanted 10 years of Dask experience required, right? Well, Dask hasn't been around that long.
Yeah. Well,
Yeah.
I think this is a separate issue, which is oftentimes the people writing job posts don't know what they actually want. And that
Hmm.
doesn't mean just like, oh, it's an HR person who's writing this job post. It could be a data scientist who thinks that they have the ability, like, I'm going to set the bar so high because our team needs people that hard. Like, that's fine. You could say this job requires a PhD and years experience in Dask and all that, and you will find no one. And then what are you going to do? Well, you're going to drop it to a reasonable level, and then you will find people. Like the fact that those terrible job posts exist is not an indication that the field actually requires that stuff. And only an indication that a lot of people don't actually have realistic expectations for what they should get from an employee.
Hmm. Hmm. You mentioned that the second part of the book talks about like why projects fail and what to do if projects are failing. What are the biggest questions you get from folks that are data scientists and are at that stage of their career where they're trying to navigate the role?
So I will say on that failure thing in particular, so I give that as a talk, and I've done it a couple of times at a couple of different places. And when I give the talk on failure, I there are some questions, but in general, what happens after the talk is I get lots of people come up to me and they're like, oh, thank God someone else feels the things I feel. Which is to say that, especially as a more junior data scientist, when your stuff doesn't work, right? If someone says, hey, go build a churn model on that customer data, and you try and build it and you just can't get it to work because there's just not enough signal there, it's very easy as a data scientist to be like, if I knew more skills, if I were a better data scientist, I could have made that churn model actually fit. When in practice, probably that data just has no actual signal in it. So no matter how experienced of a data scientist you are, that model won't fit. And I
Hmm.
think that that's kind of a problem for lots of junior data scientists in lots of different ways, which is you have expectations that the amount of knowledge and skill you have is an indication of how well you will do. But things like the data isn't actually have a signal in it, or your stakeholders don't actually know what they want this product to do. They're just asking you to build models because they think that's a good idea. And then when you build them, they're like, wait, what do I do with this? Like none of that stuff has to do with your technical abilities and knowing
Hmm.
how to like draw that like emotional boundary and be like, okay, this project failed, but it's not because of me. Or maybe it is like related to some stuff that I had to do, but like what are the things I can take as notes for the next time I do this project, as opposed to I should have known that stuff in the first place, even though this is only my ninth month on the job. That stuff's really important, and I don't think it's talked about very much in data science.
Hmm. Hmm. I imagine when you first came into the field, we were certainly a lot closer to this time where, we the data scientist was also, almost, often preceded by mythical, like the unicorn data scientists, like the someone who, knows math, knows stats, can program, can deploy, can do all these things. And over the past several years, as the field's gotten more mature, there's a lot more specificity in roles.
Mhm.
And also roles have kind of bifurcated into, now you've got folks that are, machine learning engineers that are focused on deployment. I'm wondering how, the evolution of the role has changed, or would change the advice you give to someone who is joining the field or early on in their career. Do you Is that something that kind of impacts the way you talk to folks and advise folks?
Yeah, kind of. I do think, yeah, I think when I started, there were no one had any expectation of data scientists because they barely existed. And then I agree, they got to the point where your point of now every data scientist should do everything, and now we've gotten smarter about that.
Hmm.
I think what I would tell people entering the field is it is helpful, I think, to have a basic idea of which of these things you'd rather do. Would you rather build models that are continuously running that like get hit like APIs and help customers, like a recommendation model? Or would you rather be using data to help a business make a decision? And like what you're delivering is a PowerPoint, but it's a PowerPoint filled with interesting ideas that you found out from data. Or do you want to do just not just, but do you want to do analytics, which is like, hey, I'm going to take data from a database, put it in an easy to use dashboard, get it to you so it's easily digestible, but like just making data easy to use. Like think about what are the kinds of things that sound the most interesting to you. That'd be the first thing I'd say. And then the second thing I would say is, but don't feel like you are locked into that, and don't feel like you have to like make a full decision before you start as a data scientist. Which is to say, like, one, you may think, oh, I really want to do machine learning, but then you'd happen to find a job that's your first job's the more decision science. I'm going to make decisions based on this data. You might like that. And you don't know until you really try these jobs which ones you like and won't like. So don't feel like if it's not the one you signed up for, you will not enjoy it. And then second, it is entirely possible to change. I spent the first 10 years of my career doing decision science stuff, especially as a consultant, which is give me your data, I will give you insights out of it. And then in the last couple of years, I've switched to machine learning, which is, hey, I'm going to build models that continuously run as Docker containers, blah, blah, blah. And like, was that switch easy? Not really. I mean, it took work, but like I could do it. I think other people can do it. And I think we kind of have this weird gatekeeping as a field of like, oh, you're just a decision scientist. You can't do this stuff. You never will. And it's like, no, anyone can do any of this stuff. It's just a matter of getting the experience to learn how to do it.
Yeah, yeah. So on the topic of machine learning and Docker containers and all that jazz, maybe let's start with Dask. What is Dask?
Yeah. So Dask is basically, here's how I think about Dask, right? You're a Python user. You write your Python code. It's running on your local machine. And you're like, man, I really wish this Python code was running on a distributed set of machines really easily, right? So Dask is that tool, which is to say, if you have an operation that could really easily be switched to running on a bunch of computers at once, Dask can help you do that. Like one instance is, let's say you have a for loop, and in that for loop, it does a big computation, and it goes to that for loop 1,000 times. Why not have 10 computers taking each parts of those for loops and doing them all at once? Dask will help you do that. Dask also has a lot of built-in libraries and stuff, so you don't even have to think about how do you distribute this stuff out. You could just do something where it feels like you're doing normal pandas, but secretly on the back end, the calculations are being farmed out to this cluster of stuff. So Dask is an open source tool. Right now, it's kind of like the alternative you'd use is Spark. But Spark is like, it's written in Scala, it's on the JVM, it's a house of setup. And like Dask is really like, hey, you got Python code? Take your Python code, run it on a bunch of things at once, nice and easy, don't have to worry about it. And so Dask is an open source tool that's been developed since like 2018. And Saturn Cloud, the company I'm at now, one of the things we do is we make hosted Dask easy to use. So if you are doing stuff on your laptop and you're like, I wish this was running on 100 computers in the cloud, you can like in like 3 clicks have Saturn Cloud be the place where all those computers live. And it's a really cool tool. I think it's very neat. And I think I am surprised more tools like this don't exist in other languages and stuff. Like it just seems such like an intuitive thing that it should exist. And so I'm just very happy that Dask exists.
Mm-hmm. And so when you talk about the for loop example, it echoes both stuff that was happening in like high performance computing, where you have to be very aware of the program and whether it's data parallel versus computation parallel, things like that. And on the other side, infrastructure type things like Kubernetes and distributed computing and things like that. It sounds like Dask is maybe a little bit of both.
Yeah. And okay, so people who have ever heard my podcast or anything, I'm very strongly opinionated about things. I think that as a data scientist, you should not have to worry about your Kubernetes cluster and like, oh no, is that port open and that one work? Like there's a level of abstraction you as a data scientist should not have to worry about. You should just be able to use these tools. I also think that there's for some whatever reason, when people talk about distributed computing, it is one of those topics where people love to make it unnecessarily complicated, right? Like, but is it a blah 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 type or a blah blah type? Yeah, and it's like, look, all I do, it's a for loop. I would like each one of those for loops to happen all at the same time. Just like that shouldn't be that complicated. And I think Dask is one of those tools that makes it less complicated to do that, as
Mhm.
opposed to sometimes people be like, there's some tools that make it more complicated. I think another great
Well, we
example.
went through this whole phase with Hadoop where you had to take that for loop, turn it into a map and a reduce and all that stuff in order
Yeah.
to distribute it.
Yeah, and like this is really a place where it'd be easy to do that abstraction. And Hadoop did. Here's a confession I have, which is when I was a junior data scientist in like 2012 or whatever, Hadoop was becoming really big, and everyone's like, "Oh, you're a data scientist, but you work with big data." And I was always like, "No, I always work with like 200,000 rows and like linear regressions and stuff." And like I felt really ashamed. I'm like, "Should I go learn Hadoop? Should I go learn Hadoop?" And thankfully, I never learned Hadoop, and now I don't need to because people don't really think about that. We have tools like Dask and Spark that handle that layer of abstraction. Which is, say, if you're a data scientist and you feel like, oh no, I don't use this tool yet, but I feel like I should be using this tool to stay ahead of stay on the curve. You never know, that tool might go away by the time it might be simple enough that you don't need that. Another place where I think this happens a lot is with, I think, neural networks for the longest time. Where like, oh, is it a blah layer, this kind of abstraction? And like here's a really complicated, crazy diagram, and here's 8 equations to talk about like neural networks. And like you see this, right? You see these like easy to use neural network cheat sheets on LinkedIn that are just like pages of math equations. And that's crazy. Like a talk I give is literally just, hey, you can learn how to do neural networks in R in like 20 PowerPoint slides. And it's going to be PowerPoint slides filled with pictures of pets. And we're going to be training a neural network to generate pet names. Like that is a talk I give. And people are like, wow, I didn't know neural networks are this easy. And I say this so passionately because I did, for the longest time, didn't feel like I could learn neural networks because I thought they were too complicated. And then once I learned them, I'm like, are you kidding me? This is nothing. I could learn this easily. Other people could too. And I think Dask and distributed computing is a thing that more people could do if we made this easier to understand, as opposed to like, look how smart I am for understanding this complicated thing.
Yeah, yeah.
Yeah.
So what's the user experience for a Dask user? Is it totally transparent? Is it transparent depending on what you're trying to do? Do you have to annotate or decorate your functions, or like what does the data scientist need to do to take advantage of Dask?
So there are a couple different ways you can use it. So the way I personally like to use it is just a decorator on your functions, which is like you say, hey, this is a delayed function. Don't run it right away. And then you create like a Dask, you start your Dask cluster, which may be inside our cloud, may just be on your PC, whatever. Like you start a Dask cluster, and then you say, hey, use that cluster to map that function, or, basically run those functions on this list in that cluster, or, there's other simple operations. Another way you can use Dask is like Dask has kind of wrappers. So there is like instead of using like PD for pandas, you use like DD for Dask, and then you use the same pandas commands. But what that's
Mm,
doing is it for you is doing that, figuring out how to make it into a list and sending that all to the clusters or whatever. Like it's doing all that work of turning it into the distributed code. And so like there's the pandas version of that. There's like I think scikit-learn. Like there's a lot of different um packages and stuff that have, okay, if you want to do Dask for your distributed backend, you can do that too. And those are kind of the different ways you can run it. And I will say you can, like I said, you can on your laptop be using Dask and then send it over to the Saturn cloud servers. Um, the one complexity of that is like if you're using Python 3.6 and that Dask cluster is all using Python 3.8 and stuff, like you can run into a little bit of issues. So what we do at Saturn Cloud is we host Jupyter. So you can be using a Jupyter that has like guarantees that Jupyter will be consistent with that
mm,
Dask cluster, just as like another potential way to use this tool, which is to say there's a lot of different ways you can try and run this stuff. And at Saturn Cloud, a real design philosophy is like we don't want to lock you into one way of doing things. I feel like some like data science tools are like, okay, like you want to use Git, sure, but you can only commit using this one button. And if you want to do anything complicated like branching or all these things you're used to, you won't let you because we're locking you down. And I don't think those tools usually succeed. Like usually you want your tools to meet data scientists where they are.
mhm, mhm. On that topic, um, I guess maybe a couple ways to go into this conversation. Like, where do you think data scientists are with regard to the the kind of the software development tool chain? Like, that's been something that's been evolving over the past few years. There was a point in time which Git was a foreign entity to a lot of data scientists. Now it's becoming more common for data scientists to use Git, and I often see it varies from organization to organization. Some organizations will want all of their data scientists to use Git and IDEs. Others are, hey, we're going to figure out how to make the Jupyter notebook into the Uber IDE and, productionalize notebooks and things like that. Any observations on that?
Yeah, I would say I've seen a remarkable, like, compared to like 6 years ago, a remarkable like gathering around Git. I think 8 years ago, you could be like, we're a data science team, but all of our code shared in a SharePoint, and like that would be, I've seen it. Like you laugh, but I've seen it.
Literal SharePoint.
It might have been a network drive, but it was like the data was in
Yeah.
SharePoint. It was not like a good time. I think like the message is now out that like if you're a data science team and you're not using Git
Yeah.
and version control on your stuff, that's like you have a problem. I think that message has successfully gone out. I
Yeah.
also do think in the last couple of years it's becoming more common for data science teams to use things like GitHub Actions, or
Mhm.
Docker, and like I think data scientists are like we're doing a good job of making this stuff more accessible, so you don't have to be a software engineer to use software engineering tools. And I think that's really great. Um, but that said, I also don't feel like if you don't know those tools, that means you can't be a data scientist. Merely that, like, usually, like, when you're on your first job, you will pick up a lot of these things. Like, maybe Git, you should
Mhm.
probably learn Git before you, like, hunt your first job. But beyond that, things like GitHub Actions, Docker, all that stuff, like, you don't need to know that when you're applying for jobs. A job should be teaching you how to use those tools if they need them.
Yeah. Yeah. And it is super important to realize that learning Git means some basic things, and it's there's so much to like really 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 learning Git. um but I think a lot of us know enough Git that we can do the usual things, and if we get into trouble, then it's Stack Overflow with everyone else and trying to figure out how to rebase your branches and do all this
Yeah.
crazy stuff.
Yeah, I've been using Git. God, I learned it like 2012. It's like 10 years.
Yeah.
And yeah, I feel like this year 10, I'm like, okay, I kind of feel like I get like, yeah, rebasing and stuff. Like, I feel like I kind of have like getting more experience. So, like, if you've been doing this for less than 10 years, don't feel like you should know that. And if you've been doing it for 10 years, like,
Yeah.
still probably fine.
Yeah, yeah. And you mentioned Docker and containers, Kubernetes. Those have all come up in this conversation. What's the relationship between those and Dask?
So, well, with Dask, you can run Dask like on a Kubernetes cluster. Like, there are ways to like have that all work.
Hmm.
Um, we at Saturn Cloud kind of manage that all for you. So basically, you just specify, I want this AWS image size, and I want this base Docker image. And then it says, cool, you now have a Dask cluster of that. Um,
Hmm.
but if you don't know Docker, it doesn't really matter that you don't need to know Docker to know I need this particular base image. But if
Yeah.
you're like, I want to specify exactly what's on these Dask clusters when they start, like that is a thing with Saturn Cloud, you'd specify through like a Docker container or, a post build file. And I do think data scientists, regardless of type of data scientist, it is a good thing to learn like a little bit of Linux commands. Like, what does sudo apt-get mean? What does, blah, blah, blah. Because you start to learn that, then you can pretty easily make Docker files and Docker containers and, do like kind of speak the common language of a lot of these tools. So I would recommend learning that kind of stuff. But again, I don't think that's something you need to learn before you get a job. That really I would consider a skill you can learn while you are, growing in your career.
Hmm. And so does is Saturn based on Kubernetes and all that stuff, or is it using its own pixie dust under the covers?
I am not on the engineering team, so I don't want to say because I know I'm going to get it slightly wrong, but I believe we do have a Kubernetes cluster. And like, well, what we usually do is we, because a lot of times we are being hired by enterprise to like run, like an enterprise doesn't want to have their data pass all the way to some other person's AWS, whatever. So we install Saturn Cloud in your company's environment. And I think we set up one Kubernetes cluster within that
Mm,
like VPC or whatever.
mhm.
But I'm just spouting words. I don't know exactly the intricacies of this. I'm much more on the using Dask than setting it up side.
Got it. Yeah, and I think we skipped right by that. What is your specific role at the company? What are you focused on?
Oh yeah. So as head of data science, I help the data science team. So we do things like, helping customers get up to speed with Dask and Saturn Cloud. We also, develop white papers, blog posts, things like that. So like we're kind of like the internal team that uses this tool and helps other people use this tool. And in addition to that, it's a lot of product development too, because this is a tool for data scientists. So if we're using this product and we're like, oh, we find this part of it, complex or unintuitive, then we are the ones to kind of say, hey, we should be prioritizing this kind of solution. Which is, again, it's nice because I think compared to a lot of technical products for data scientists are still built by software engineers. And so you kind of get that feel of like, are they, I'm not sure the people designing this understand what data scientists do every day. And I do not feel that that is the case with our product. I feel like, well, I like to think I'm doing my job, which is making that easy, but who's to say really?
Mhm. Um, is there a particular use case or set of use cases that you see more commonly among Dask users? Are there specific signals or indicators that say, "Hey, this is probably going to be a good place to apply Dask"?
Yeah. So I think that, I mean, it's kind of the same as like any parallel distributed computing, which is if you're running out of memory because one machine isn't enough, then Dask is a good solution because it can spin up to arbitrary amounts of memory, right? Because everything is split over a bunch of computers. So if you're running out of memory, that's a good sign you need Dask. Or if you have one thing that's running, but it's taking forever, and you're like, man, I could probably chop this up into smaller tasks. Then Dask is great because if you can chop it up into smaller tasks, um, you can then put it in a Dask cluster. And including like most common pandas commands and stuff. Pandas, you can switch pandas to Dask and then use these sorts of tools. So that stuff's a pretty good sign. Also, I will say, with Saturn Cloud, we have it all set up to use GPUs just as easily. Like with no setup, it's just you hit go and the GPU CUDA drivers or whatever already correctly installed and stuff. So, if you're like, hey, I need to train 10 neural networks and compare how well they do, well, like, wouldn't it be nice to train all those 10 at the same time in one Dask cluster? Or, you can, in fact, in PyTorch and stuff, say, hey, I have this one neural network, and this neural network is too big for one. Even a computer with several GPUs is not enough GPUs for this neural network to train. And so you can get a Dask cluster where each computer has a bunch of GPUs and like you connect all to. I don't think that's a common use case, but like it if you're there. If you're like, I just do not have enough GPUs running at the same time to do this kind of work. And I think Dask is a really nice solution for a lot of those.
And is Dask equally useful for folks that are doing kind of traditional tabular data and analytics types of workloads as opposed to neural nets, media files, that kind of thing, images, or
Yeah,
is
I
it
think it's
more one or the other?
No, you can do it. If you're not doing like neural network and stuff, Dask is still totally useful. There is a penalty if you're switching stuff to like distributed parallel thinking. There's a penalty if it's going to take you a little bit of time to like rewrite, rethink the code of like, hey, this one for loop. Okay, yes, I can split it or whatever. Can I split this for? Like, you got to put a little thought into it. And I think if you're training on like a 50 kilobyte file, then like I don't think you're going to get much benefit out of the effort of switching to Dask. But I do think if there's a lot of situations where it's like, I have a huge data set, and yeah, what I'm doing is training a linear regression or whatever. I have a huge data set, but what I'm doing is simple. Even in that case, because the data is so big, it is still faster or more convenient to just have it go on Dask rather than trying to get it to take forever on one machine.
Mhm. Is it used equally in the data processing, transformation part of the workflow, or exploratory analysis part of the workflow, training part of the workflow? Is there any particular sweet spot, or
Yeah,
do you
so
see it
so
across the board?
a couple good places. Training models can be very good on Dask because you can train a bunch of models at the same time, or you can train one model across a bunch of them. And we have customers who do that at Saturn Cloud. Another thing that's really useful for is Yeah, like a scheduled daily processing job, right? Where if every day you take your entire company's data and you're trying to calculate some aggregated statistics and then put that into a new table, you can schedule that to run every day and have it scheduled to run on a Dask cluster, and then it will be faster and you won't run out of memory and things like that. And then at Saturn Cloud, we have customers who don't use Dask at all. They just like the ability to just start and stop, data science instances and start and stop GPU instances and start and stop instances that have like 500 gigs of RAM. So for us, just having the ability to have one computer easily accessible in the cloud has been useful. But that is all just to say that there's a lot of utility in having these sorts of data science resources readily available for data scientists.
Cool. Any thoughts or thoughts on like where the tool is going and what folks should look out for?
So I think it's just one of these things where it only came out in 2018, so it's still quite
Yeah.
young. Which is just to say, I think there's going to be a lot more, taking other packages and getting them to run within Dask directly. I think continuously making the tool easier to use, creating new documentation, things like that. And so Saturn Cloud uses Dask, but we're not the only company that does. And so there's lots of people contributing to this, which is kind of cool. I've never worked at a company where we were so directly involved in the open source community, and that's been I don't know, it's been a lot of fun. I've been really happy with that.
Mm-hmm. Nice. Well, Jacqueline, thanks so much for taking the time to chat with us and bring us up to speed on Dask.
No problem. No, it's been a lot of fun being back on the show. Yeah. And now at what point do I become friend of the show, Jacqueline Nolis? Is it like one more?
You are friend of the show, Jacqueline Nolis. Absolutely.
Great. Well, yes. Thank you for having me.
Thank you.